Okay, we're rebatting a plane. We're using oblique plane worksheet number 8. It's on page 108 as the example of the question. So we've got a lamina, in other words a triangular piece of perspex, flat surface, 1, 2, 3. Here it is in elevation, here it is in plan. We have been asked to find the true shape of it. Now, if we wanted to find the true shape of a plane, normally what we do is we take an auxiliary elevation, auxiliary plan to find the true shape. So in other words, I would take a horizontal line on the plane, find that in plan. Here is my horizontal line, and I would project an auxiliary elevation looking along that line. So I'd project an auxiliary elevation out here looking along that line, and then I'd project an auxiliary plan off that to find the true shape. We've got a second option here, and sometimes it can work out quicker, especially on a question like this where you're given the traces of the plane, for example. So what we have here is we've been given the traces of the plane, we're going to rebat the plane. What that means is, if you look at my set square here, I've got a plane 1, 2, 3. It's oblique, in other words it's twisted at all sorts of angles, but it's still a flat surface 1, 2, 3. What I can do is to find the true shape of that, instead of me setting up auxiliary elevations and auxiliary plans to find the true shape of it, I can get that plane and I can lay it down flat on the ground. And what I'm doing, you'll notice, is I'm using the horizontal trace, so where the plane hits the ground, as a hinge. So I can hinge that down. So I can drop it in this direction to lay it down, or I can drop it out in this direction to lay it down. It doesn't make any difference. It would still give me the true shape of that piece of perspex, or the true shape of my triangle here. It doesn't matter. That is what we call rebatting a plane. So getting the plane, hinging it down so it lays down flat in plan. So we can see either of those is my true shape. To do that, we still need our auxiliary elevation. We didn't need to draw this line though, because we have the horizontal trace. So in other words, a horizontal line, we're looking along a horizontal line, so those two lines will both be parallel. I'm going to project out my auxiliary elevation now. So again, auxiliary elevation, fairly straightforward. We look along a horizontal line. So that horizontal trace, or the line I drew, should be parallel. So I'm going to look along my horizontal trace. I'll take up point 1, 2 and 3. And I'll set up my XY line at 90 degrees. So exactly the same as we normally would. So auxiliary elevation, looking along a horizontal line. X1, Y1 line is set up. I take my heights. Height of number 1. Again, it's an elevation. There's number 1. I'm drawing an auxiliary elevation, so it's the same heights. So there's number 1. Point 2. Here's the height of point 2. And point 2 when I project it up is here. Point 3 when I project it up. Here's the height of point 3. This should form a straight line. That is the auxiliary elevation of the plane. If I extended it to hit the ground, it will hit down here. So in other words, here is the entire plane, the bigger plane, and where it hits the ground is my horizontal trace, HT. So that's point, is a point view of the horizontal line HT. So I've got points 1, 2 and 3. Now I can rebat the plane. So what I can do is get my plane, and I have my auxiliary elevation, and I've got an edge view of the plane. I can do that laying it down flat at the ground, like I was showing you with the set square with the piece of paper stuck onto it. So now I can get the plane. Here is my plane, and I can swing that around and lie it down flat on the ground. So what I've done is I've taken the whole plane and swung it down so it's flat on the ground. And again, I've used my point here, which is HT. All of the points swing down flat on the ground. So when I take point 3, 3 swings down, 2 swings down. So now point 1 has swung down onto the ground, 3 has swung down onto the ground, 2 swung down onto the ground. So I've got my points. I can now come back and draw my new plan. So I've had an auxiliary elevation, I've flipped the plane into a new position, I need to draw the new position in plan. To do that, I take my point back. So parallel to my HT line, which is where I projected out the view, I project them back in. So 2 is going to come back in, 3 and 1. So I projected the lines back in for each of those. Now I need to find the points. They will all come at 90 degrees to that HT line, because that is my hinge line. Everything's going to move around that at 90 degrees. So when I come along, I find point 1. I'm projecting 1 out at 90 degrees to HT. Here is 1, 2 and 3. That is the true shape of the plane. And so what I've done is I've taken 1, 2, 3 in plan and I've flipped it down flat onto the ground. This is my true shape. And that is rebatting a plane, so laying the plane flat down on the ground. So just run back through it then. Height to point 1. The height I took for point 1 was taken from elevation. Then I took point 1, I swung it down onto the ground because my XY line is the ground, back into my plan view, and then took it out here, and the important one at 90 degrees to my horizontal trace. And that's the process. Repeat for each of the points.